everyone, I am Suryansh Pandit of class 7. So today we are going to continue the same chapter, rational number. If you have not seen my previous video, there you can find an I button there. So in that you will see, you can click on that and you will go to my previous video which I have made on rational number. There we have discussed a lot more. So if you will directly jump on this video, you will not understand anything. So you need to see my video which I have made previously, and so you need to see that, and then you will be able to understand it quite well. So in that video I have told you that let's do a quick summary that rational number in form of p upon q and like 5 upon 6 minus 5 upon 6, and there are two types of rational number, negative rational number and positive rational number. This we have discussed in our previous video, and I have told you that we will going to start with the properties of rational number. There are some properties of rational number, so let's get started. So there are many properties of rational numbers. So first we are going to start the closure property. Let me write CLOS. It's closure property. And what is closure property? Closure property are the sum or the difference or the product of any rational number, any two rational number are always rational number, right? 2 upon 3, let me take one example. 1 upon 2 into 3 upon 1 is equal to 3 upon 2, which is a rational number, right? 3 upon 2 is a rational number. It is in the form of p upon q, so it is also a rational number. Its product. Now let me change the question. If it is of minus, so then we need to convert it like LCM. Now it will come 6 upon 2. Then 1 upon 2. Let me change the question as it. We will discuss it. So 6 upon 2 minus 1 upon 2, which is equal to 5 upon 2. Right? So it is again a rational number. The difference of two rational number is always rational number. Now let's change it into a product. So then also it will be 6 plus 1 is 7 upon 2. Then again it is a rational number. So now let me twist the question. That the question is 1 upon 2 divided by 3. Right? You can see that 1 upon 2 divided by 3. Right? So you can read the question. I am asking you a question that is division comes under closure property or division is closed under closure property. I am giving you 10 seconds. 10 seconds. Yes. So many of you or some of you got that correct. That division is not closed under closure property. Now let me tell you why. Half of 3. What is half of 3? 1 upon 2 means half. So what is half of 3? Half of 3 is 1.5, right? Is 1.5 a rational number? No. 1.5 is not a rational number. It is a decimal. 1.5 is decimal. Yes. So, is division closed under closure property? No. As 1.5 is not in the form of P upon Q, it is a decimal. So, it is not a rational number. So, division is not closed under a rational number. क्योंकि closure property says that that the product or anything of rational number like product, subtraction, division, or anything, if you divide it, then it should be a rational number according to closure property. But it is not. It is a decimal. So division is not closed under closure property. Now let's come to another property, that is commutative property. Now what is commutative property? Commutative property of rational number means reverse of that question, like 1 upon 2 into 3 upon 2. Right. 1 upon 2 into 3 upon 2. Can we write like this? 3 upon 2 into 1 upon 2. Can we write that? 1 upon 2, like it is 1 upon 2 here. So we just reverse it. 1 upon 2 into 3 upon 2. It is here like this. So we will just put this and this here, and it is on first number, right? First. It is on second. In commutative property means the reverse. So if it is first, 1 upon 2 is first in this question. So we can write it in the last also, in the second number also. Like, let me tell you in the variable form, A into B is equal to B into A. A was on first, it came on last. B was on last, then it came on first. Just the reverse of that. Let me give you one example of that. 1 upon 2 into 3 upon 2 will be equal to 3 upon 2 into 1 upon 2, right? 1 upon 2, yes, 1 upon 2 is A, so A will come on last, so 1 upon 2 is on last, right? Okay? Yes. So I can tell you, I can show you how it is. A like 1 upon 2 into 3 upon 2 is 3 upon 2, right? 3 upon 2 into 1 upon 2 is equal. It is also equal to 3 upon 2, right? So it is all under multiplication lies under that commutative property. Now let me ask you one question. Okay, let me ask you one question, that is addition under commutative property? Let me give you an example. A plus B should be equal to B plus A. Let me verify it, right? 1 upon 2 plus 3 upon 2, which is 4 upon 2. And when we will simplify it, it will come what? 4 upon 2 will come what? 2, right? 1 here and 2 here. So it would be 2. Now let's see here also. 3 upon 2 plus 1 upon 2. It is also coming the same, 4 upon 2, and then if we will simplify, it is coming 2. Both are same, right? So can we say that it is close? It is under addition also. Commutative property is under addition also. Now what about division and subtraction? Let's verify it, right? It's fun verifying things. Like it should be a minus b should be equal to b minus a. Yes, should be equal to. I'm not sure that it is. So let's verify it. 5 minus 3 or 5 upon 2, 3 upon 2, it is equal to 3 upon 2 minus 5 upon 2. Right? So what is 5 minus 3? Tell me. 2. So here comes 2 upon 2. And now what is 3 minus 5? Minus 2. Minus 2 upon 2. Right. Right? So there in b minus a there is coming negative and in a minus b it is coming positive, right? So is minus 2 and minus 2 upon 2 and 2 upon 2 equal? No. So can we say that it is closed, subtraction is closed under this commutative? No. Because they are not equal. So a minus b is not equal to b minus a. So it is not closed under commutative property, right? Yes. Now, is division closed under commutative property? Let's verify. I would say no. But how can you believe on me? And let's verify it. If you don't believe me, let's verify it. It's fun, right? So 1 upon 2 divided by 3, or let me take another number. 1 upon 2 divided by 4, right? Yes. Should be equal to 4 divided by 1 upon 2. Yes? So let's verify. 1 upon 2 into 1 upon 4 is equal to 1 upon 8. Okay. Now what is 4 divided by 1 upon 2? Let's verify. It is 4 into 2 upon 1 and it is 8. Yes. 4 divided by 1 upon 2 is 8 only, and 1 upon 2 divided by 4 is 1 upon 8. So there is a lot much difference between 1 upon 8 and 8. It is a lot difference, right? Right? So can we say it is closed under commutative property? No. So division is not closed under commutative property. Only addition and multiplication is closed under what? Under what? Under addition and multiplication. Division and subtraction are not closed under commutative property. Okay. Now let's jump into another property, or we can say it an identity, and that is multiplicative identity. What is multiplicative identity? I don't know. Let's see what I said. Multiplicative identity is the one whose product is 1 into whose, when it will be multiplied, it would be there would be 1 in that. Let me give you one example. 1 into 1 upon 5. 1 into 1 upon 5. What is 1 into 1 upon 5? It is of course the same number, 1 upon 5. Yes. So multiplicative identity is the number when the number 1 is multiplied by any number, any rational number, any natural number. It should be the same rational number which we have multiplied from 1. Like 1 into 1 upon 5 is equal to what? 1 upon 5, the same number. So, let me explain you in the variable form. It is a into 1 is equal to a. The same number. Right? Like 1 into a is equal to the same number a. Or a into 1 is equal to a. The same number. So if I would say you to multiply this. So, what would be the answer? Tell me. Of course, the same number. This. It was so long question, but it was very, very, very easy. The same question. Right? So that's it. Multiplicative identity is the number when multiply any rational number when multiplied from 1. It is the same rational number. Now, let's go to the associative property. Associative property is what? It is what? Let me tell you in the variable form, and then we will see the examples which visualize the variable. When we will do with variable, it would be more easier to understand. But when we will do with the numbers, it is also easier. But when we do with the variables, it is much easier. It is very much easier with the variables. So let's try to do with the variables. A into B. Let's say into only product. A into A means let's do it as C. Yes. Or we can write it A into B into C. Anything. Right. Let's write it clearly. B into C. It is just the bracket shifters. Like A into B bracket, B into C. There it would be A into B would be in bracket and C would be outside. Here A is outside. Here C can be outside. Here C can be outside. Associative property is that only. Simple, right? Let me give you some examples of the same. Yes. 1 into 2. 1 into 2 into bracket 1 into 3 into 1 upon 4. This should be equal to, it consumes a lot of space. So let me write in a smaller way. 1 upon 2 into 1 upon 3 into 1 upon 4 is equal to 1 upon 2 should be in bracket into 1 upon 3 into 1 upon 4. Okay, so what is this? You can see the question. Let's prove it. Right, it's a good idea. It's a nice idea. 1 upon 2 into 1 upon 3 into 1 upon 4. So let's solve. First solve the bracket. 1 into 1 is 1 and 4 into 3 is 12. And 1 upon 2 is on bracket, and then we'll open the bracket. To open the bracket, we will multiply the bracket first. So what is 12 into 2? 24. 12 2s are 24. So it would be 1 upon 24. And what is this? First let's solve the bracket part. 1 upon 6. Right? And then we will open because as we have multiplied it. So what is 6 into 4? 6 4s are, let me write it in a clear way. 1 upon 6 into 1 upon 4. What is that? What is this? 6 4s are what? 6 4s are is what? 24? So we will write 1 upon 24. So is LHS equal to RHS? Yes, 1 upon 24 is equal to 1 upon 24. So can we say associative property is closed, or like multiplication is closed under associative property, right? Now let's verify if it would be plus. So the same formula. Yes. So let me do it for you. Let's take 1 upon 2 plus 1 upon 2 and like that only. Let's take it. Yes. So let's start. 1 upon 2, right? Yes. 1 upon 2 and let's say yes. 3 upon 2 plus 4 upon 2 should be equal to, let me write in a smaller way, 1 upon 2 into, plus 3 upon 2 plus 4 upon 2 should be equal to 1 upon 2 plus 3 upon 2 plus 4 upon 2 and this in the bracket. Sorry. Yes. Right? Yes? So let's solve it. 4 plus 3, what is that? 7. So 7 upon 2 plus 1 upon 2. So as the bracket is opened, so 7 plus 1 is 8. 8 upon 2. So let's cross it. It will come 4. Let's simplify it. Yes? Now let's solve this part. So what is 3 plus 1? 4. So is equal to 4 upon 2 upon 2 plus 4 upon 2. Yes? Bracket is opened. So we will multiply with the same. So what will come? 4 plus 4 is 8. So 8 upon 2. And then we will cancel it 4. So LHS is equal to RHS. 4 is equal to 4. Right? So LHS is equal to RHS. So can we say that addition is closed under associative property? Yes? Yes, you're correct. And we can say the same. Now let's verify is division or subtraction closed under associative property? Let's verify it. Let's change all of this in subtraction. Yes? every part of this property. This property is very useful in order to do the same. And in the next video we will also learn how to do addition, multiplication, division and subtraction. So please stay tuned, and please don't skip the video, as it is the property part is very main part. So let's continue. Yes, so 1 upon 2 minus 3 upon 2 plus 4 upon minus 2 minus, and this also will be converted into minus, right? Yes? Can you see that? Yes. So what is 3 minus 4? What is 3 minus 4? It will be minus 1 upon 2. Minus 1 upon 2. It would be minus would be plus. So 1 upon 2 plus 1 upon 2 is what? 2 upon 2. Which is equal to 1 only. Now let's see there. It is minus 2 upon 2 minus 4. So it is minus will be plus. So 6 upon 2. So of minus. So it would be what? Minus 3. Is minus 3 equal to 1? No. Minus 3 is not equal to 1. Is it? It is or not? It is or it is not? Tell me. Yes, you are correct. It is not equal. So can we say that subtraction is not closed under associative property? Yes, can we say this? Yes, we can say this. Now let's verify the division method. Let's verify, is division close to the associative property? Let's see. 2 upon 1 divided by 3 upon 2. Let's suppose it would be 3 upon 2, the same number. It would be easier, it would be very easy. For you all also to do the same. It would be 2 upon 1 divided by 3 upon 2 divided by 3 upon 2. Yes? Let me write in a clear manner. Yes. 2 upon 1 divided by 3 upon 2 divided by 3 upon 2 should be equal to 2 upon 1 divided by 3 upon 1 is divided by 3 upon 2. Yes? Right? Yes? Tell me, yes or no? Yes. So let's see if it is equal or not. So let's first do this. So it would be 1 only. 3 upon 2 divided by 3 upon 2 is 1. 1 divided by 2 upon 1. So it would be obviously 2 upon 1 into 1 upon 1. Should be 2 upon 1 only, same number. Yes. So here it came 2. Now let's verify here. 2 upon 1 so it came 2 upon 3 here. When we solved bracket, it came 2 upon 3 divided by 3 upon 2. Let's check it out. So it would be into 2 upon 3 only. Here it came 4 upon 9 and here it came 2. So LHS is LHS equal to RHS? No, it is 4 upon 9 on one side and 2 on another side. So it is not. So LHS is not equal to RHS. So the division is not closed under associative property. Yes, so now let's do additive inverse. So what is additive inverse? It's very simple. Additive inverse is the reciprocal of the number. Okay, so there's one word I said, reciprocal. Reciprocal. So what is reciprocal? Reciprocal is, let's understand in variable again the same thing. A upon B will be equal to B upon A. A upon B is equal to B upon A. Ulta. A upon B, then A is in the numerator and B is in the denominator. So it would be, denominator will come above. Like, let me give you one example. 1 upon 2. Yes, the biggest example. 1 upon 2. What is the reciprocal of 1 upon 2? It is 2 upon 1. Yes, that's it. So additive inverse means reciprocal of the number. Yes. So what is multiplicative inverse? Tell me, what is multiplicative inverse? First, before starting multiplicative inverse, I also want to tell you one more thing. The additive inverse, like A upon B, there is the reciprocal of minus sign. Keep in mind. I said that in the additive inverse of that part would be B upon A, right? And we also use minus, negative sign. Like it is A upon B, so we will write minus A upon B. Simple. 3 upon 5 it is. So it would be minus 3 upon 5. Yes. In fraction, I told you that if there is a without fraction or rational number, without rational number. In the rational number, there is a twist. Twist is that 3 upon 5 additive inverse would be plus 2 minus. Okay. There's a twist, right? Like 3 upon 5 means, like 3 upon 5 is additive inverse is minus 3 upon 5. Just the change of minus. It's simple, right? 2 upon 3 is equal to minus 2 upon 3. Simple. Right? Now let's jump into another topic, which is multiplicative identity. We have done multiplicative identity, but there is also one more thing, multiplicative inverse. What is multiplicative inverse? Multiplicative inverse is that which is reciprocal of itself. In rational number, additive inverse is just the change of negative there, and multiplicative inverse is the reciprocal of the same number. Simple, huh? 3 upon 5, what is the multiplicative inverse? 5 upon 3. And what is the additive inverse of 5 upon 3? Minus 5 upon 3. As we cannot put negative sign in the denominator, so we can take it as the negative sign in the numerator, just in the numerator. Okay, so that's it for this video, and we will meet tomorrow and with the with the same chapter but new topic. What will be that new topic? Yes, it would be addition, subtraction, multiplication, division. Bhai, we have to start the new exercise 1.1. So first we need to do addition and subtraction and multiplication and division. That's it. And then we will start exercise 1.1. Okay. So thank you everyone, and yeah, please don't forget to like, share and subscribe my channel, and please comment also. Okay, so bye bye everyone, and yeah, please subscribe my channel. Bye.